Hello, everyone, and welcome to week 5 of Introduction to Citizen Science and Scientific Crowdsourcing. This week we'll focus on digital technology design for citizen science, which has 3 parts. And in this part, we will see why design is important, what is human-computer interaction, and some key terminology. This part of your module is explicitly based on the book Geographic Citizen Science Design, No One Left Behind, which you can all download using this link. I suggest that you have a look at mainly chapter 3, which is where you will find most information about the methods we will be talking in the third part of this lecture, as well as in the materials next week. So, over the last 5 to 10 years, citizen science has become increasingly popular. You should all know by now what citizen science is, and you must have an understanding of the different types of projects or activities in citizen science. There is a plethora of new technologies and new ways which enable citizen science projects to recruit volunteers, as well as a range of digital devices and sensors which enable volunteers to collect, submit, and verify data. You must have observed that there are different types of citizen science activities involving different levels of skill and commitment. According to several studies, typically people who get involved in citizen science tend to be middle-aged, middle income, and usually have some college education. Also, more women than men tend to be involved, but this depends obviously on the context of participation. Now, we should make a note that not all people have the same access to technology or citizen science, and that is because of where they live. They do not, for example, have access to internet and Wi-Fi networks. They do not have the same kind of devices, education levels, experiences, or even the same skills that are required to use technology. These all impact whether people can use supporting technologies, and therefore how easy to use technologies is a significant issue as within citizen science, as it is motivation for sustained participation. Some of the decisions that we make when we design citizen science applications will influence or should be informed by who will use the application. And here you can see different examples on the slide. Kids collecting data, and workshop developing a prototype for a citizen science application, which will be used by older women who do not have experience in using smartphones. Also, people in Kenya collecting data from medicinal plant properties. These volunteers have very different characteristics, which all need to be taken into account in the design of the citizen science application. Another design decision refers to where the application will be used. Is it going to be used, for example, in the rainforest or in a busy urban center? Is there access to electricity in this place? And if not, how people will charge their devices? Are they going to use the application to collect data while doing something else or not? Of course, what is going to be used for is one of the most important elements that should influence how an application is designed. Focusing on providing these functions and visualization and not other ones that should not necessarily serve what the application should be used for is key. Some examples for relevant design decisions here include: is the application going to be used to collect data points, such as different kind of species within a particular location? Is it going to be used to collect information, as for example in bird watching within larger geographic areas or even worldwide? Is it going to support some kind of complex analysis afterwards, such as filtering for specific time periods, adding layers of different information to examine data in parallel? Or is it going to be used simply for disseminating data and improving scientific understanding of, say, an endangered species? Obviously, design decisions are influenced and should be informed by similar questions. Another question is when it will be used, and this might be more relevant to hardware choices. Is it, for example, to be used in extreme sunlight? The brightness of the screen might be key here. During the winter, when there is, for example, heavy snow and people wearing gloves, you need to consider how your application is going to be used. If a touchscreen display is used to collect data, or is it going to be used in areas during periods of heavy rain? You might need special waterproof equipment for your devices. Also, will the application be used in areas during times where users collect information that sometimes these puts their lives even at risk, and where audio or even the brightness of the screen might cause them trouble? Design choices and technological choices most of the time go hand in hand. On that front, we might need to consider things like the most appropriate technological infrastructure, which further meets the needs of specific user audience or help reach new audiences and so on. In fact, a common issue which is faced by most decision makers in citizen science projects from the early stages of setting up an initiative is that of choosing the most appropriate technological infrastructure to facilitate data collection, analysis, and dissemination. This is usually accompanied by a lack of awareness of the technological front, or in other words, technological availability, and most importantly, the limitations and opportunities that specific technologies may bring to a project. These decisions are inseparable, and they are further destined to influence that technology, the way that technology will be eventually utilized, and how by its end users, and therefore they have a direct impact in the success or the failure of a citizen science initiative. Any technological consideration and research for a solution should keep a broad view and examine the entire ecosystem in which a technology is developed. And again, the previous questions that we've seen in the previous slides should not only form the design choices, but also the choice of the technological infrastructure to be used in the project. Going back now to the design challenges, the fact that citizen science activities attract people of different ages, backgrounds, and interests has its own design challenges. These include the need to design interfaces which help people to attract people and retain volunteers, to design user-friendly applications to enable volunteers with diverse skills and experiences to harness the potential of citizen science and collect accurate and high-quality data, to generate, of course, user experiences that match those that users require, and so on. Also, we mentioned before that the majority of citizen science and geographic citizen science activities and applications have been focusing on a very specific demographic of Western, educated, industrialized, and developed participants. And from a geographical point of view, most efforts have been concentrating on urban centers of the global north. This, of course, leaves behind a significant proportion of the population, particularly less privileged citizens in non-urban centers of the global south, who may also benefit substantially from using citizen science and citizen science applications. However, the technological solutions that are developed in the Western world usually ignore the unique environmental, cultural, user characteristics, and other contextual characteristics which influence successful technology adoption and utilization in these areas. So, although still gaining ground, these and other design challenges have slowly started to attract the attention of citizen science and the human-computer interaction communities. So, having just mentioned human-computer interaction and some key terms in the previous slide, let's look at those more closely and provide some definitions. So, human-computer interaction is the discipline which investigates how humans interact with computerized systems and technological artifacts, and it provides the tools and methods and theory which can help improve this interaction. These methods help you to place questions about who will be using the application, when, where, what for, at the center of the design choices, and develop applications which will have the potential to be useful, and so on. Now, a term which we'll frequently encounter is that of usability. Usability is a measure of the effectiveness, efficiency, and satisfaction with which specified users can achieve specified goals in a particular environment. Another key term is usefulness, which is the system appropriateness for a specific context in terms of supporting users to achieve their intended goals, and it leads to technology acceptance. And of course, user experience, which focuses on the design of experiences that the digital products and services generate. Such experiences emerge from the integration of perception, action, motivation, and cognition. So, although usability and usefulness are key elements of the user experience goes a little bit beyond that and looks at emotional, affective, experiential, hedonic, and aesthetic variables. So here are the references we used in this lecture. For more information on the topics of this part of the lecture, please check this chapter in the book that I've shown you early in the slides.